What's going on, guys? This is Chris to Goat, and today we're going to go over a very simplified guide to what is blockchain. So specifically, we are talking about cryptocurrency. But in order to understand exactly how crypto works, we're going to have to first get into a few basics on blockchain itself. So we're going to dissect the word. The very first part of the word being block. This is an individual transaction which occurs on the network. So one way that you can apply this to real world situations that you could relate to is, let's say that you go down the road to a gas station and you use your debit card or credit card to purchase a candy bar and some gas. So that transaction is actually going to be considered a block. And then for every transaction, let's not say just for you, for that particular gas station, every single transaction that happens there gets added to a ledger, basically a piece of paper that they're writing down the daily activity, all the receipts, all the money in, all the money out. So the term chain comes together because all those transactions are chained together. So per location or per person that goes in to purchase something. So you have individual transactions that are all linked together in order in which they happen. So far, that's what blockchain is, the term that's used whenever we're talking about cryptocurrency. So there's multiple blocks, which are transactions that have individual information. They're all put together, which we're technically calling a chain. And this is visible on the public ledger. So this would be the same as a bank sending you a statement at the end of every month, letting you know everything that you have done on your account. The difference is on cryptocurrency is that's a public ledger that's maintained by the network. So basically it's visible at all time and nobody really gets sent it. Everybody has a copy of it to verify the legitimacy and accuracy of all the activity going on. So blockchain, the reason for it is it's a technology that's designed to have information added and stored, but not altered or manipulated, because the same copy of information goes to every single computer running on a network. It's going to be impossible for one computer to decide to change some of the facts or some of the words or some of the content and then push that through to try to make it legitimate for other people or for other nodes to accept. So the security behind blockchain is actually very significant, because after everything is recorded and documented, it's put on a public ledger and it has a timestamp and it has a verification. So you can't go in there and change it without going in and changing every single computer on the network, which, depending on the cryptocurrency you're looking at, could be hundreds of thousands of users. So all transactions are distributed to all nodes and supernodes on the public ledger for the specific network. So we're going to make this even simpler. Let's say that every single ATM in your town is going to be a supernode. So every time that somebody goes to one of those ATMs for a certain bank, for just one bank, anytime somebody uses that ATM, it's going to send a copy of that transaction to all other ATMs. And that's effectively blockchain. One thing happens, everything that's in a like pool or in a like sense is going to share that information with one another, so everybody's up to date. Everybody knows that you've taken out however much money from your account. Everybody knows what your withdrawal limit is. Everybody knows how much you have left to where you can take out, or how much is left in your account for that matter. That's going to be what this information is used for, and this goes to all of the ATMs, so that way you're not going to take out more than what you have, or you're not going to be, taking out more than what your daily limit is. So this is kind of a very simple way to look at how nodes and supernodes operate with the actual ledger. So it's going to be just like an ATM. Every time you go to use it, it's going to share that information to the other ATMs, so that way they're all on the same page with you and your account through the bank. So we're going to go through some very basic graphics here. So over on the left-hand side, we see a block of information. Again, this is a transaction which occurred on the network, so that's going to be what this demonstrates for our PowerPoint today. On the left we have Adam, on the right we have Andy. Adam wants to send Andy 30 coins. So as you see above Adam, he has 30 coins and it's going to go over to Andy. So the question is, how does this work? So first we're going to talk about how this works with a bank. Right in the middle we have our bank. At the top we have our executive. Obviously you can see spying, no privacy, and you can see the control of the money. The bank oversees the transactions. Now here's the funny part. If the bank shuts down, so does the network. If you're ever told that your bank has a virus or there's any kind of situation and they shut down, you will not have access to that money. That's the crazy part. That's centralization. That's one person, one entity, one bank controls the finances of the customers. As soon as something happens to it, it completely shuts down. Not to mention, more and more often, banks are being hacked and manipulated through DDoS attacks and other methods. So we need to be very, very proactive in avoiding any kind of unsecure public ledger, public information, or public banking system that cannot guarantee the privacy of your coins. So this is what the entire purpose of blockchain is to go away from the bank. So I guess the question is, how does this work without a centralized bank? So the individuals act as the bank, and as you can see below, we have a little simple network. So we're going to try to go through a demonstration, little illustration to show you exactly what it is we're talking about. Okay, so again, we have Adam and Andy. So in the very middle is a very basic view. Let's say we have 5 computers in our network. 4 of them are normal. They're on sometimes, not all the time. Just people who like to use their computers, so they don't have it dedicated. The super node down in the far right, that's going to be a computer that somebody has on 24/7. The entire purpose of it is to act as a bank. So that way it's verifying these transactions. It makes sure that Adam has enough money to send to Andy, to make sure that the wallet address is correct, to make sure that when the money is sent, that it's going to go through and go to the proper person, the proper address. So on the left-hand side, we see the money, and we also see the block. So that's going to have to go through all of these nodes and the super node to get to Andy. So as you can see, next to all of the nodes or super nodes, there's already 3 blocks. So this is my version of what a blockchain would look like on a very simple level. So all 5 of these computers have already agreed to and gone through 3 transactions. So that's the information that's recorded for all 3 of those transactions as it gets distributed. So as the money gets sent, it leaves Andy's wallet. Now it's in the very middle here. So now you can see the money follows the paper or the block. So this is where it all gets verified. The information gets sent to these 5 computers here. These 5 computers are going to work together to verify that this is accurate, that the information's cool, that Andy had enough, or Adam had enough money to make sure that it's going to the right place, to make sure that everything matches up, just to make sure there's no issues. And at the very end, excuse me, that ledger is going to disappear here, and it's going to go back onto all of the other 5 stacks. So that means that that money has gone through the transaction, through the network. Those 5 computers verified that that Adam had enough money to send to Andy to verify that everything was okay. So then that paper or that block is added to the chain. So that's just basically another notch in the belt, or another signature done, or another task completed by these computers. So they add this visible information to the public ledger to show that a transaction has already come through and has already happened. So this is kind of a simplified chart on the whole process in which everything goes to. So from a bank, things go from you to the bank, to the individual, and there's a lot of power that goes with that because there's a lot of fees that are associated. Again, they know everything that you're doing. They if they have any kind of issue and they shut down, then that's going to be it for your particular currency. So looking here at this chart, we're going to see the sender, and it's going to go through a long network of nodes and supernodes. All these nodes and supernodes verify this information. They can be individuals from all across the world, every corner of the globe. All people who have an invested interest in the coin and whatever it is. So all these different blocks will indicate a new computer. All these computers are passing through your information from one another just to make sure that everything is accurate. And then it eventually ends up down there to the receiver. So let's imagine that 3 of these squares were blanked out in red and were no longer part of the system. The rest of the network would continue to operate because there's so many different individuals that are involved, as you can see from this, that you don't have to worry about downtime. The problem is with a bank, as soon as it's down, it's down. So how is this decentralized? There's no banks, only coin users. So again, there's no centralized authority in a blockchain that watches it or maintains that information or maintains any of the network itself. That's all done on the individuals. Computers or programs are designed to verify transactions. So it could be an old computer you've had out in the garage, or it can be a program that's designed by the coin. You download it, and basically you are becoming part of that decentralized network to where you are one of those nodes or supernodes. So you have the ability to verify and to record those transactions. The network of volunteers runs the nodes and supernodes for rewards. A lot of coins, when you verify transactions, you get rewarded with certain amounts of coins of that currency, which you can sell and trade. That's an incentive that most people operate on. So to answer the question, why would anybody want to create a offline bank effectively? Well, there's always rewards that's involved. But of course, you're being part of the system that's pulling away from the system. So that's also a large draw for a lot of people. Even if some nodes or supernodes fail, the network will continue to operate, and there's no downtime with that. It's kind of like what we just had talked about. If a handful of computers does go down due to power or internet issues, there's still going to be other options in other countries on all the time, always connected. So there's never going to be a concern that things cannot happen. There's no centralized government or organization to control, spy, or watch the activity that happens on the blockchain, which is really cool. Like I said, that's something that to me and a lot of other people, privacy is huge. So when you go into blockchain, there's not going to be anybody that can manipulate or tell the customers what they can or can't do. Basically, it's a train going crazy, hauling down the tracks, and there is nothing that's going to stop it. And the network of people just keep shoveling coal into the oven and are ready to hear the whistle blow. Maintained 100% by the global community. And so that kind of just sums up everything that we had just talked about. So this is a quick example on what a network would look like. Again, we have Andy and Adam. So in the middle there, you see all these webs. So each one of those person silhouettes is going to be a computer that's part of the network. The big ones are the supernodes. The small ones are the nodes. So basically, this would represent every computer on the network, on a small scale rather, that is going to be sharing all this information. They all have the same piece of paper saying who all sent who all, how much. All of them are on the same page. All of them are up to date. All of them are connected to the internet. And any time that person A on the left sends money to person B, it has to go through this network, and all has to be verified before it gets to them. This piece in the middle is global community. This global community is what replaces the bank. People, volunteers, they become the ones that verify those transactions, not the actual bank itself. So again, the ledger, or on the left-hand side of the block, will get sent through the network, which is in the middle, and after it gets verified, all of the blocks will be added to each of those people on the network. This is how everybody makes sure that everything has happened correctly. All transactions can go back and be checked if they need to, and that everybody is operating correctly because everybody is sharing the same information. This is a successful transfer and also the end of our show almost. This is going to show you exactly what it looks like whenever everything is accepted. So a transaction was sent through this network. As you can see by the 5 check marks, everybody agrees and accepts the information. So this means that the block was added to the chain, and these individuals are just getting started on that chain. As you can see, they just have one block next to their name. So this block is going to contain information such as the destination of the funds or the wallet that they're being sent to, the accurate information on who, on how much, and for why, even on some currencies, a transaction timestamp to find out exactly when and where and the date that took place of the transaction for any disputes, as well as the names of the sender or receiver. So this means that a block has been sent to the network and everybody has verified that it is correct and accurate. However, when we go to this one, you can see on the bottom left-hand side there is an X. So what that means is that the transaction would not be accepted because for some reason or another, there was false information that was added to the block on this one computer down there. So that's going to get rejected because the other ones do not agree it to be real. So basically, it's going to be a majority consensus. If a couple of rogue networks or nodes or supernodes decide to try to send an attack in or send false information, a transaction that didn't happen, or more money than they have in their account, there's built-in securities that will find that, and they will reject that, and they will actually remove that node from circulation so that it's no longer part of the decision-making process. So this is how there is added security away from having one person that verifies or one individual company that verifies all transactions. So everything is up to the community completely. However, things are way more secure, things are more trustworthy, and things are there in black and white for everybody to go back and look at what transactions have happened, the same as you can with your bank. So we get into the final statement of cryptocurrency and blockchain is not evil. It's just a little complicated. But once you understand that you're replacing the bank and the banking system with individuals and the volunteers that want to be part of that network, everything's easy to go. Thank you guys so much for checking out this video. Please leave a like, comment, subscribe, all that fun stuff down for us. In the video, please make sure to mention if you want us to have any other videos or any specifics to focus on. If you want us to make a video specifically on cryptocurrency instead of just blockchain, let us know, guys. We're happy to help you out. You help us out, so we're going to work together. Thank y'all. Peace out, and have a good day.